We're way past the point of just talking about flying cameras. We are standing right on the edge of a brand new era, one where our machines can actually think for themselves. So, in this explainer, we're going to dive deep into how AI is giving drones a mind of their own. So, let's just start with a really big question. What if a drone didn't need a pilot? What if it could size up a complex situation, make its own call, and see a mission through from start to finish, all by itself? And look, this isn't some sci fi movie plot. This is the reality that's being coded and built as we speak. To really get a handle on this revolution, first we need to understand the incredible leap we're making, a leap that goes way, way beyond just a simple remote control. Okay, so what's really key here is who's in the driver's seat. Over on the left, you've got the classic setup that we all know, a human pilot calling every single shot in real time. Seriously, just think of it like a remote-controlled car. But on the right, well, that's where everything changes. An onboard AI is making the calls. The human gives the mission, the what, but the AI figures out the how, even reacting to stuff that pops up unexpectedly. It doesn't need that constant link back to a pilot, kind of like how a self-driving car navigates its way through a busy city. So, how exactly does a drone learn to think? Let's get into the brains of the operation, the specific AI tech that actually makes all this autonomy possible. At the very core of this whole learning process is a concept called reinforcement learning. And honestly, the best way to think about it is like training a puppy. When the puppy does the right thing, you give it a treat, right? Well, the AI drone works in a pretty similar way. It tries out different actions, and when one of those actions helps it get closer to its goal, it gets a little digital reward. After millions, and I mean millions of these trials, it just naturally learns the best way to behave, even in really complex and uncertain situations, all by itself. And here's that learning loop in action. First, the drone uses all its sensors to sense what's going on around it. Then, its AI brain has to decide on the best possible move. Next, it acts on that decision. Maybe it adjusts its flight path or changes speed. And finally, the system gives it a reward. That's the feedback, positive or negative, that makes its decision-making just a little bit sharper for the next time around. It's this constant, non-stop cycle of sense, decide, act, and learn. But to make smart moves, a drone has to be able to see, and that's where computer vision comes in. With these advanced AI models, a drone doesn't just see a video feed, it actually understands it. It can spot specific objects, track them, and tell the difference between a healthy crop and a sick one, or a bird and another aircraft. And believe it or not, it gets even more complex. What about groups of drones working together? This is where you get swarm intelligence. It's totally inspired by nature. Just picture a flock of birds or a school of fish moving in perfect, beautiful unison. There's no single leader barking out orders. Instead, each drone just follows a few simple rules and communicates with its neighbors, and out of that emerges this incredibly intelligent, coordinated group behavior. Okay, so this all sounds amazing in theory, right? But where is this technology actually making a difference out in the real world? Let's take a look at some of the applications. The impact here is, well, it's huge. We're talking about autonomous drones in defense, of course, but also in things like agriculture, spotting crop diseases from the sky to help farmers get better yields. They're inspecting bridges, speeding up search and rescue missions after disasters, and even helping us monitor the environment. This isn't just some niche gadget. It's a total game changer for a ton of different industries. Let's just take a concrete example. In farming, an AI-powered drone can fly over hundreds of acres and use its computer vision to spot the tiny telltale signs of a crop disease way earlier than a human ever could. Other models are being used to autonomously count livestock, which saves farmers an unbelievable amount of time and effort. Okay, this one is just amazing. I mean, can you imagine the precision it takes for a drone to autonomously land itself on a power line? This isn't just some cool tech demo. It's for inspecting critical infrastructure in places that are dangerous or almost impossible for people to reach. And it could even be used for recharging itself to stay on mission longer. And yeah, in defense, the applications are pushing the absolute limits of what autonomy can do. These systems can fly reconnaissance missions in hostile airspace, identify potential threats, and constantly recalculate their own flight paths to stay safe and get the job done, all without direct, moment-to-moment human supervision. But the real paradigm shift, the truly mind-bending part, comes when we move beyond a single intelligent drone and start thinking about the incredible power of the collective. So, one autonomous drone is an impressive tool. There is absolutely no doubt about that. But what happens when you have more than one? What happens when you have 1,000 of them all working together, all sharing information, coordinating their actions in real time? Well, then you get something entirely new. You get a swarm. So, the crucial point to get here is that a swarm is so much more than just a lot of drones. It's resilient. If you lose a few units, it doesn't really matter. The mission keeps going. It's adaptable, able to surround a problem or change its formation on the fly. And through cooperation, the drones can divvy up roles in real time. Some can be the eyes, others can be communicators, which makes the whole system unbelievably efficient. And all of this brings us to what is probably the most important question of all. As these machines get more and more capable, what is our role? How do we work with them? I mean, this is the big one, right? When a machine can make its own tactical decisions in the blink of an eye, we have to completely rethink what it even means to be in charge. How do we make sure a human is still in the loop in a way that actually matters? Okay, this slide breaks down two really key concepts. Human in the loop means the AI can do all the hard work, find a target, line up the shot, but it has to stop and wait for a human to give the final yes or no. On the other hand, in a human on-the-loop system, the AI is fully authorized to act on its own, but a human supervisor is watching and has the power to step in and hit the brakes. The difference might sound subtle, but in practice, it's incredibly important. Because at the end of the day, we have to be able to trust these systems. That means building something called explainable AI, so we can look back at a drone's decision and understand exactly why it did what it did. It also means having rock-solid fail-safes, clear rules for human oversight, and doing the hard work to make sure the AI's training doesn't create some weird, unintended behaviors. And ultimately, this quote really nails it. This is what it's all about. By integrating AI, we're creating systems that can take on really complex missions in dynamic environments, which frees up humans to focus on the bigger picture. And that leaves us with one final thought. We are moving from an era where we simply operate tools to a brand new era where we partner with intelligent systems. And that's going to require more than just new tech. It's going to require a new way of thinking, new rules, and a completely new understanding of the relationship between humans and machines. The revolution isn't just up in the sky. It's in how we decide to approach the future itself.